Today's first session is on earthing of DG, UPS, electronic equipment. As a part of today's requirement, a competent earthing design is an absolute prerequisite to protect lives from the harmful effects of high voltage, which exist during fault situation. This session is a high-level intuitively based view across the topic of earthing. Here we have Mr. S. Appavoo, General Secretary, NFE, former Electrical Inspector, Government of Tamil Nadu. He is an electrical engineer, certified energy auditor, and a freelancer in advising electrical safety and earthing practices. His experience includes earthing installation design practices of LV and MV installations as per CEA regulations. With warm greetings, we welcome you, sir.
Good morning, everybody. Slideshow.
First slide. Okay.
Slideshow.
We'll see there on the screen.
They
will do it later.
Okay.
This no.
So, good morning, everybody. In today's, my presentation today will deal with some slides on generator sets with regard to the earthing, paralleling, and four-pole braking. And the main subject will be focused on mitigation against conductor and radiated emissions for the proper functioning of sensitive devices. So I am referring the matters from Central State Authority MSES Regulation 2010 and IS 732-3043 as well as IEEE 1100 with regard to the UPS configurations and its earthing practices. Because people are doing much of confusions on earthing with regard to the sensitive equipments. So I have to refer that standard. So as per this slide was already dealt with by Mr. Gopa. Okay, this linked switch. I am concerned with the linked switch because our subject will be focused on neutral integrity and earthing of DG sets. So I am concerned with the linked switch. So as per regulation 15, in the neutral circuit, there should not be anything, no cutout, link, or a linked switch, nothing. If it is continuous, then the integrity will be assured. However, there are some practical difficulties, practical considerations that warrants link for testing purpose and a switch for controlling a generator. That is a four-pole changeover switch. So for this only, this regulation, the prime purpose is there should not be any break. That's why the standards 3043 clearly describes only a link for the neutral. See, for the parallel operation, the neutrals are connected through the link. Unlike the phases, they are having separations. So only the outgoing circuit for the load circuit alone will be having the four-pole. See, this is the difference. Here only we have a solid link. We can avoid a break here. But people invariably provide four-pole breakers in all the way. In main panel, during inspection, we see that there are breakers, invariably four-pole breakers at the incoming, outgoing, everywhere. That should be avoided. And the latest provision in NEC as well as IS 732 strongly recommend a single point earthing. Since I have already told that the focus will be on neutral integrity and a common point, a single point earthing is advocated. So all the neutral, particularly this length will be insulated. If it is a switchboard, this point will start from the switchboard only. So then only there can be a single point earthing. This is the intent of the standards as well as the regulations. And as per CA regulation 45, it insists interlock. Interlock means when there are two or more generators, if you want it to operate in parallel, then the linked switch shall be interlocked to prevent any inadvertent feedback or paralleling. That is the 4-pole. Here only we are using the 4-pole breaker. Here you can see the voltage exceeding 650. It should not be misinterpreted that your 415 volt DC sets don't require these things. This is only for the insulation. The CE regulation, there are 3 chapters, above 250, above 650, so above 33. So the 650, don't interpret that it is required for the ST generators alone, because in some places people are misinterpreting this. It is for the installation, and it includes a 415 volt DG set also in the ST premises or installation 650 volt and above. So naturally you will be having lot of 450 volt DG sets even at LT premises like multi-story building premises. So the neutral integrity should be achieved. What we infer here is all generator inverters are first connected to the neutral bus bar, the main LV switching gear, then only this will be connected to a bolted link and to an earthing conductor. Here we provide neutral integrity. Then the regulation also, here it is that when neutral switching is adopted, it is only a choice. It is not necessary you have to go for neutral switching. Because in olden days, DG sets were having some circulating current because of winding, end winding and other issues. Now things have improved. So the circulating current will not harm much. Actually, the neutral isolation invariably we are providing is alone providing some flaws in parallel operation of DG sets. We are having suppose we are having 4 or 5 DG sets, even 10 or 20 DG sets in IT establishment. There are group of DG sets, 1 5 set provided with a series of neutral contactors. Suppose if anything goes wrong with the actuation of any of the contactor or the logic missing, PLC, something missing, then there will be a major flaw in the system. The over voltage will always be there. The phase to neutral voltage will be a line to line voltage. So in order to avoid, we can avoid the neutral switching. That's why the regulation clearly provided when it is provided, it is parallelly operated and neutral switching is adopted. So it's only a choice. So we have to go for avoiding neutral contactor in parallel operation. So anyhow, they are having the manufacturers also we have discussed, they are also ready to go for this configuration without neutral switching. Though we have to, in future installation, we have to go for paralleling arrangement without neutral switching. Another thing, this is a logic. If you put the neutral switching, these logics will come into picture. So this everything will be avoided by this.
Sir, just please go back to the previous
Sir.
previous slide.
Yes.
Just wherever your cursor is, so that between two sources, so that earthing point, should that be at the source at which is generated or at the switchboard? Is there something which you are saying?
No. See, the source will be at 2 places.
Yeah.
There are more than one source parallel operation.
So if there is
So,
a
so
short,
it is better to provide it at the switchboard.
So if there is a fault in the source one, for example, say a transformer, so now the nearest switchboard, so why should the fault still flow towards the switchboard and then gets into the system? This is a basic debate which is in one of the projects which I am having.
Oh,
There's a CIG approvals and various discussions are going on. So we say that in the transformer we will give you the neutral brush and the bush and the earthing. That's at the source, but they say you should be doing it at the nearest switchboard. So there's always two different engineers think differently but look for the same solution. So what's your view on that? Should it be only at the nearest switchboard? In my view, if it is switchboard, then again you are taking the fault towards nearest switchboard. If there is a fault at the source itself, that's my point of asking.
okay. So if we provide something here, you want, suppose if you provide here with neutral switching,
Yeah.
then again a neutral break can happen for one of the generators.
Okay, maybe we can take this offline, but I want to discuss with you.
Okay,
that's
okay.
Because it comes to the inspection in the authority to discuss.
Yes, there is some,
Yeah.
there is some clarity. I know that there is some clarity to be discussed with the CAG department
Correct.
also.
Correct.
We will discuss.
Yes, so sure. This
Huh?
is not in Chennai, but this is in Maharashtra.
Yes.
And definitely
See,
there are different ways of looking at it.
Yes, generally people say rules, CAG rules in Tamil Nadu, CAG rule in Kerala, CAG rule.
Yeah,
in
exactly.
It's
So
not like that.
that's one
The
school of
rules are
thoughts.
common. The interpretation is different. That's why I have shown the interpretation in that next slide.
Okay.
In some states, they say that it is applicable for 6 feet generators are more than 6. So these are all interpretations.
No problem. I will not waste.
Maybe right or wrong,
No,
but
I will not
interpretation.
waste everyone's time, but definitely I want to discuss with
Ah,
you.
sure, we will add this.
Thank you.
Yes, thank you. So we all know that without 4-pole, this is a figure from IS 732 figure 39. So with the 3-pole, it's naturally we will be having a circulating current. I need not explain this. There will be a circulating current. Only by 4-pole only you will cut down the circulating current. That's why a 4-pole breaker is provided. And here, this is a standby generator with star point switching. See, these are all the complications for the when star point switching is involved that I have already discussed. See, this switching should be interlocked with the breaker so that the logic is maintained. Any one of the neutral shall be in circuit and the neutral of the functioning generator will always be in circuit. And another thing, neutral should make before the poles and break after the poles. So these are all the logic. Suppose if there is any miss due to, I don't think a PLC logic there will be a miss in logic, but there will be a miss in the contactor's operation and neutral pole engaging. That's why I say that it's always better to avoid. Then the purpose of the thing we are concerned with this final point only, the referencing of neutral to avoid neutral shifting and to minimize electrical noise interference in sensitive services. What is the noise? Noise is nothing but an added voltage in the phase to neutral. Normally, electronic gadgets or sensitive devices will be having a common reference, a metal frame will be there. So there will be, those points will be earthed, that will be having a reference. So naturally, we will give a connection to that metallic part. Suppose if we give a connection and that connection itself is infested with some circulating current, I will explain on the slide. Then there will be an ordered voltage. For example, a noise, that we call it as a noise voltage. It can be of high frequency or low frequency or supply frequency. For supply frequency voltage, we call it as a conducted emission. For high frequency, it don't require sometimes above 30 megahertz. It won't require a conductor also. It will be a radiator. So we will be having two type of noises. One is conducted and another radiator emission. In conducted emission, the noise voltage will be propagated via cable and other things to other circuits also. For example, VFD drives are best example. And another thing, if there is a a very heavy motor in the same feeder connected for the UPS circuit, then during the switching on of the motor itself, there will be a noise voltage developed during switching on or off. And radiated emission, as I already told, it is a high frequency propagation. So EMI is the capacity, is the quality of a device, a apparatus. For example, an X-ray machine or MRI scanner, they are all EMI sources, electromagnetic EMI waves. They produce EMI, electromagnetic interferences. They will cause interference. And EMC is the ability of the device. You should withstand some devices, they can't withstand more than the prescribed level of EMI. So, for example, it's an echocardiogram in a hospital, then it will be very sensitive. It can't withstand more. If you place a radio antenna or a cell phone, mobile phone within the vicinity of that machine, then the results will be distorted. So that is EMI, that's a EMC. The compatibility of a sensitive device without undergoing any malfunctioning in its function or in its results. So how circulating currents in normal frequency, supply frequency, how circulating currents are created. Suppose in one way, if you provide a neutral, multiple neutral earthing, the current, instead of going towards the source through the neutral, there will be an additional path will be created. So this circulating current will be having a voltage drop across the PE conductor that can be imposed on the equipment. That will add to the, because everything is working on the bytes. If additional bytes or additional voltage is impressed, then it will create malfunctioning. Certain equipments can withstand some neutral to earth voltage to certain level. For example, a desktop computer can withstand more than 5 volt, or laptop cannot withstand, and even some servers, they should be so sensitive. So depending upon the sensitiveness of the equipment, the neutral to earth voltage will also differ. In the buildings, why dedicated earthing? People are providing dedicated earthing. Suppose if you are providing earthing for the building rebar and the equipment without interconnection, see, during the lightning, suppose if there is a 10 kA stroke and your equipment, there will be a capacitance from the roof to the equipment. Suppose if there is a thundercloud above the roof, it is actually air is the best dielectric material, but due to pulling out of outermost electrons, it becomes a plasma and has become a beautiful conductor to discharge the lightning to the Mother Earth, where it has occurred the electrostatic charges. So even a kilometer's length of dielectric material can be disrupted, means there will certainly be a kilovolt from the rooftop up to the equipment. Suppose if you are connecting the frame of the equipment to one earth rod and the rebar to another earth rod without interconnection, there will be any potential equalization. So we should not provide a dedicated earth. It's a dangerous practice. And single point earthing again comes into picture. For example, if there is a device here which is plugged in and there is an interconnecting cable from another device, see, the circulating current, the circulating earth current will always be there. There will be two currents, one through this, another through this. So this circulating current may cause disturbance to this equipment. The best way is to provide a single point. You provide earth connection as cable as well as the plugging everything from the same source. So your earth current will not find a path. It will come and go away. There won't be any circulating. It's a simple solution for insisting a single point earthing as well as single source I can say that is a single source. So how to mitigate the noise voltage at supply at low frequency? This is avoid multiple earthing of source and provide single point earthing and avoid isolated earth electrode. And this important thing is effective and localized. I will explain the subsequent slides. You should adopt a localized TNIzed earthing system and avoid galvanic connection. Then insulated earth conductor as a functional earthing, as Mr. Gopa yesterday in his presentation put forth this view. So this is only a functional earthing. This is no way connected to the protective earthing. This is a proper functioning of the equipment. And triplen harmonics, for example, in harmonic device, we are all having latest gears with harmonic, all harmonic generating devices that will naturally have a path towards a neutral, causing a neutral voltage rise. Another thing, integrity of neutral and availing separate circuit from the main panel. This will minimize the conducted emissions and harmful voltage sag when a heavy motor starts. You should not have any heavy motor connected in the same feeder. And we should always observe the mandatory requirement of supplemental bonding, that is frame of UPS. You should be connected to the equipotential bonding conductor. That people should not isolate. I will say where this particular point will be valid in the subsequent slides. So I have shown only one configuration. This will satisfy all. Suppose this is your transformer. This is your incoming transformer, mains transformer, where the neutral and ground is connected. This is the TNS system. So this will come up to this UPS module. Actually, in modern days, in olden days, there are UPS with MOSFET and other devices. They can't take much voltage. They can't withstand much voltage. They were providing some isolation transformer to the incoming as well as at the outgoing sides. But with the IGBT and other interventions, they can take 415 volts directly. So nowadays, UPS are coming without transformer, so transformerless UPS. So in the transformerless UPS are finding a common place in all IT buildings, where how to mitigate the noise, how to avoid conduction of noise voltage from the raw power to the equipment side, is to provide the best way is one logic, one rule is you have earthed the neutral here. So this is the output side of UPS. Here again you should not connect. Here this is separated. You should not connect. This is rule number 1. So to avoid multiple earthing. And here you can see, if you have the best practices, if you have a distribution center and there is a dB, we can provide an isolation transformer, one-to-one isolation transformer, where you can have a neutral. Here the supply is galvanically separated. There is an isolation transformer, there is a galvanic separation. So here your neutral should be interconnected with the ground and connected to the earthing electrode. This is the TNS system for the downstream computer loads. Without this, once this is provided, then the downstream equipments will be seeing this reference only. Any noise or other unwanted local noise will get dissipated from here, and there won't be much noise interference to the downstream equipments. And another way, there are transducers located at faraway places from the source, from the isolation transformer. This isolation transformer and this is a panel for the sensitive equipments. There is a receptacle, say it's a transformer with isolated receptacle. So it can be an insulated one. Here what we can provide is to provide an insulated earth, so that the insulated lead, this is a functional earth. This is no way attributed to the protective or eco-potential bonding. This is a functional earth for the transducer, and that will be connected, that will be taken through the DB. There need not be a much physical separation to avoid an inductive effect. That will be placed closer to the cable and in the ground bus, then it will be connected to the source neutral. So this is the thing. And here what you can, the benefit is you can have your transducer directly referenced to this source, thereby avoiding any transferred voltage, noise voltage impressed to the transducer, thereby affecting the proper functioning of the transducer. But this is not suitable for device where the frame is earthed. Then you have to go for the previous module only. So far we have seen how to mitigate the low frequency noises. So isolate. So if you have a transformer-less UPS, you isolate, have a galvanic separation, preferably at the distribution board. Then you have a localized TNS connection. You can't expect, then you can avoid the noise voltage transferred from generator or transformer sources, which could be ineffectively earthed. And noise voltage at high frequency. So really, these are challenging issues whenever the noise from high frequency. That high frequency, they don't require any conductor. There are some parasitic, inductive and capacity coupling will always be there. That is invisible capacitance will be there. During the high frequency 1 by 2 pi fc, when the denominator f goes beyond 30 megahertz, your capacitance will be drastically reduced, and there will be a circulating current. That will become a source for conducting the high frequency noises to your system. Here, the signal cable between interface like modem, fax, hubs or printer router, these are the sources, how they are transmitted. And the VFD, EMI from other sources like VFD during lightning discharge, switching surges. And the electrostatic discharge also one of the reasons, and harmonics. So, earthing design for high frequency should address some other approach, not like a conventional low frequency approach. It requires the knowledge of traveling waves and inductive effects. See, we know that traveling waves are in various wavelengths from gamma rays to radio waves. As far as the frequency increases, the wavelength decreases. That formula I will show. See, the wavelength is proportional to the speed. It's an electromagnetic wave, almost speed of light, through 3 into 10 to the power of 8, divided by the frequency. So, for 50 cycles frequency, the electromagnetic wave will travel up to 990 kilometers. So, there is a factor accounting for the velocity factor. If you apply that factor, then it will be 990. So, any transmission line will be a long line. So, we can't have a 990 kilometer transmission line. So, nothing will happen for a power frequency 50 cycles supply. Suppose if it's a 20 kilohertz involving switching surge of 1.2 bar 50 microsecond, then if you apply the formula, it will be around 2.5 kilometer only. After 2.5 kilometer, the first wave peak would have traveled to the end, and there is no conductor, it will be reflected. That is a wave propagation theory. And at 50 kilohertz, say 8 bar 20 microsecond lightning surge, see, we say, electrical engineers say this is 8 bar 20 lightning surge, and electronics people say it is 50 kilohertz wave. So the distance will be around 1 kilometer. So any lightning conductor positioned after 1 kilometer of a substation will become ineffective. Any equipment to be protected from your substation will become ineffective if it exceeds 990. And if it is a VFD drive, see the length, after 165 meter, it will be radiated. It will become antenna. The end of the cable will become antenna, it will be reflected. And 30 megahertz, see, it will be 16.5 meter, and 100 megahertz, you see, this is a radiated emission, just 0.5. So everything will be radiated beyond this point. So what are the limits, how to mitigate? So separation in any mitigation, in EMI mitigation for high frequency, separation is a must. It should be, of course, NSHC of NEC recommends certain measures. For example, separating distance will be as per the following table. Some table have been given, and it can be of 0.1 microtesla for EMG and 0.2 microtesla for EEG, 0.4 for ECG. In one of the hospitals we have, during the safety audit, we found that an ultrasound system was giving, it was malfunctioning. Because then we analyzed the brochure from the medical engineers. There is no coordination among the biomedical as well as the utility engineers. Neither the utility engineers have the knowledge of equipment or the biomedical have the knowledge of earthing. So there is no interaction, there is a missing link between them. So another important point is they do not see what is the brochure given by the recommendation given by the manufacturer. When we visited and we saw that the manufacturer recommendation itself is clearly saying that that is EMC, electromagnetic compatibility. That ultrasound system for the particular brand, there should be a separating distance of more than 2 meters. So we should always abide by the manufacturer recommendation. They guarantee their equipment. So from the mobile phone or Bluetooth or LAN devices, that has an operating disk. This is the exact recommendation given by the manufacturer. And we happen to see the mobile chargers are plugged into that same terminal where the ultrasound system is also availing supply. So then we we made some restricted entry. Actually, we had to shift that particular equipment to another location because of some other lift and other major loads are also there. During switching operations also it may malfunction. So that was shifted. Just by shifting to the second floor, it was beautifully functioning. So the separation is one of the important aspects. So these are the standard separating distances given in the IS. And another thing is a signal reference grid arrangement. And this is nothing but whenever a high frequency EMI, high frequency EMI is generated from these devices, then you connect all to the grid. So just like an earth mat in the EHV substation, if those are all connected to the grid and a very short, flat braided conductor, because the width and thickness determines the inductive effect. Higher width and lower thickness reduces the inductance. So as far as possible, you provide, that is a false flooring with earth grid arrangement is provided in the computer. This is the basis for such arrangement, especially in medical equipments as well as IT building. In medical equipment installation, what we have seen is a system, a PC was not working. Then we noticed that there was right below it was at the first floor, right below the PC, desktop computer, there was a MRI scanner. During the initial erection, the MRI scanner, the shielding, everything should be pakka for MRI or PET scan as well as X-ray. They are high incident energy sources. So the wall, everything will be, some protocol will be there to screen the EMI so that this EMI is not transmitted, harm the other equipment as well as persons. There could be some missing in the shielding itself. But when we shifted the PC to some other place, some 5 meters away, it was functioning. So separation is an important aspect. Here, what we can do is you provide single reference grid arrangement and connect all the metal frame of such EMI devices, then connect it. So the things are separation, 3S, separation, screening. First you will see what is separation and SRG. Then this I have explained, flat foil strips and multiple flat strips. And however, SRG is not suitable for equipments at different areas of building. Suppose if there is one area here, another area, you can't interconnect and have the high frequency waves drained or mitigated. At every location you should have this SRG, or you should accommodate all the SRG plan to the equipment bases in one place. So VFD drive panel, in one place we have seen VFD drive panel and a PLC panel was located in the same cabin. But whenever a TDS meter was brought inside that room, it was malfunctioning. Instead of 2000 TDS, it was an agricultural research industry. Instead of 2000 TDS, it was showing 1000 only. When it was brought out, it was showing some other location, showing very good. So separating sensitive instrumentation devices from such high frequency sources is important. Another thing, cable trays, they plays a major role. So it is a very good, material offers a very good EMI reduction property, but the equipment end connection should be in conduit. They provide earth flat everything up to the cable tray, up to the end point, then it is left there itself. It should be interconnected to the equipment. Then parallel unscreened power cable and IT equipment requires separation. Suppose if you provide unscreened cable, some separation of 35 meters should be there. Then signal reference only. So shielding is another way to absorb EMI and radio frequency by means of.
Go back to the previous slides. So parallel unscreened power and information requires separation if the length exceeds 35 meters. Okay. From the source.
Which one, sir?
The fourth point, if you can explain more in detail.
Okay. Parallel unscreened power and information technology requires IT cables. So it is missing.
35 meter means what is the meaning, sir, in that?
It's as per IS, it's in IS 732. But of course, if it is not practically possible, then you have to go for fiber optic cable, depending upon the.
Okay, we have to go for screened cabling.
Suppose if we don't have a screened cable, this will become.
Now, can we use screened cable for IT and then unscreened for power? Will it mitigate?
No, for power, you should always use armored cable only.
Armored we will use. That we will use. For the IT, we need to go for screened cable.
Yes, for EMI, whenever a high frequency interference is there, then you should go for screened cable.
Thank you.
So these are the another ways of reducing or providing shielding to observe EMI. A metallic cover in the form of armor, that is a screening, and equipment itself. There will be some equipment, you can provide some conductive paint on the inner surface of the equipment itself. And shielding should be done at both or at multiple locations if feasible for enabling attenuation of EMI sources and undesirable signals. Yesterday, some people asked during the tea time about screening. I don't know that person is here. I will show you, sir, that how the power cable, it is not connected with the subject, how the power cable screening, earthing at one point, at another point, at the midpoints. I will show personally. Some person, I think, is not today. Okay, we will discuss. So the thing is, earthing of shielding should be done at both or even at multiple ends. So I would like to conclude that you assess effectiveness of TNS earth connection. Provide isolation transformer for localized TNS. So in fact, if a rule, a mandatory requirement is implemented, you provide TNS as a must, then most of the problems would have been solved because of TT and other things, integrity. So everything would go at a single step. Most of the installations we require TNS in medical installation, IT installation, in multi-story building, then with this TT. See, for supply continuity, we can't say that you be safe, don't avail supply. Supply continuity is more important. That is also possible with this gas. People fear that TNS will be detrimental to the supply continuity. That can also be prevented by proper coordination. I think Krish will explain in his subsequent. So, observe the signal reference plan technique and screening, separation, surge diversion, low frequency blocking technique. These are other things. So, finally, you always adhere to the mandatory equipotential bonding. That is, once you provide the functional earthing or reference earthing for the sensitive devices, you should not forget the protective mandatory equipotential bonding for the safety of personnel and equipment. So with this, thank you all for your patient hearing. Yes.
Previous slide.
Previous. Third point. Single point earth connection.
Where is this multiple source neutral earth for mitigating low frequencies? The source neutral is getting, earthed at the source only. It's not getting, multiple places earthing is
People are doing.
Acha.
Practically people are doing in LT installation. You may not be doing in LNT. They provided, and the one slide I have shown, what the electricians are doing is, if the neutral to earth voltage is there, they will simply connect the neutral to the earth and show this neutral to earth voltage I have reduced 0 volt. This is practically happening by the local
This
electricians.
is stunning.
That's not required for LNT.
Sir, this happens mainly when UPS earthing is there, no? The incoming earth is connected, neutral is connected to UPS neutral. There people again earth the neutral. That's what happened. Basically it happens in UPS systems. Your incoming neutral will be connected to UPS output neutral. Then again your neutral should not be earthed because your neutral is already earthed transformer. That's what is a multiple earthing. It should not happen.
See here, see this slide. It is connected here. Also it is connected here. There is a galvanic separation, it's connected. Suppose if an electrician sees and the consumer complains, so my neutral to earth voltage is here, he will connect it here also. This will involve a multiple. That time he can show that neutral to earth voltage is less. But during the proper functioning of the equipment, it may be ideal situation. During the functioning, there could be a neutral current due to harmonics or even due to load unbalancing.
Sir, in screw chillers, we are having the VFD drives or in centri chillers, whereas we are having the PLC also. But we can't avoid, you are asking for the separation. One of our data center site, which we are facing this EMI interference, how to mitigate? Because your screw chiller for part load efficiency, I want to have the drives.
Yes.
Same way I want to take it on M2M, I am having the IoT PLC. But I can't have a separation very closely.
No, does your PLC requires a visibility with your VFD panel?
Yes. This PLC
What?
actually I am having the display when I am
So
having the
see, PLC is, for example, PLC is here
Okay.
and VFDV is adjacent. Does it require a direct visibility from the PLC?
No, that is not required
Then
because
you can have segregation. Otherwise, you provide isolation transformer for the PLC
isolation transformers.
panel and earth it provided. Normally, the PLCs and conflict between PLC and the VFD will not be much. But if you provide a meter inside, then there will be a total mess and the meter will not read correctly.
One more thing is when initial coordination we are not having the equipment specification. Example ultrasound. Recently we have done Apollo Proton Cancer Hospital. This proton machine itself we are not knowing the specification, but you are telling one of the application where ultrasound you have isolated the loads.
Yes.
Those kind of things, any mitigation can be done earlier because in time constraint we will not be having the initial details.
Actually, when you are investing several lakhs of amount to an equipment, missing brochure is a very peculiar thing. You can demand the supplier, at least you give me a brochure, you give a soft copy. This is a IT era, you can get it downloaded from the website also. Some brochures are available in the websites also. You get it, you demand and get it from your supplier.
Sir, one moment. For this case, there are some electronic design standards, ISO standards available. For example, MRI machine, there is a ISO standard available. If you look at that ISO standard, whatever the kind of MRI machine, its requirements, EMI requirements are included in the standard. So you should do the design based on that particular, considering that standard as well. So you follow the standard. So then the vendor's catalog is immaterial. Vendor's catalog is immaterial. So design standards are there, you follow the standard. Similar is the situation, for example, with communication system. Communication system is changing day by day. After 6 months, something new is going to come. Now, for example, communication, whether it is symmetric or asymmetric, whether it is common mode or, within two wire system or 3-wire system. Lot of questions are there. These principles has to be applied based on your application. And for that, there are standards available.
Power cable. No. Let us be precise. You want the armor earthing of your power cable to an equipment. So it's no way connected with these things. You should be connected with both ends. What's the doubt in it? Armor serves two purposes: mechanical. It prevents the cable from mechanical injury. It provides an effective screening, and it suppresses the EMI from outer EMF. It's a very good EMI suppressor.
Yeah.
So
I just
you
want to know whether there is any
earth at
revision.
both ends. You utilize that provision.
Sir, I have a question on this equipment earthing. I have a question on equipment earthing. So when there are two sources, when there is a normal transformer and it is supported by emergency DG set. So can we have different earthing systems for the transformer and DG, or they need to be with the same earthing? No. I mean, when it both should be whether high impedance or low impedance, or can that be different for the transformer and DG?
See, Mr. Gopa, can you answer this, or it will be covered within your, because it will be a lengthy one.
Sir?
During that verification subsequent, because for the sensitive equipments I am dealing with, I can answer, it will go along.
Thank you, sir. No problem.
Thank you, thank you. If you have any doubt, we can have it clarified during the tea or lunch or up to evening. I am at your disposal.